Welcome back, students. In this particular video we will talk about realization of half subtractor with NOR gates. And we know that equation of the difference is given as A XOR B for half subtractor, and then like we did in our previous videos regarding half adders with NOR implementation, we have written A XOR B as AB bar plus A bar B, and we have used some terms here like BB bar and AA bar, because we know from the property that A into A bar is 0 and B into B bar is 0, so they shall not affect our equation. Then we have taken things common, like from term 1 and 2 B bar was common, from terms 3 and 4 A bar was common, so we are getting the two different terms. Now what we are going to do, we are, let us suppose, going to add two complements at the top. And again we know from the property, if there is a variable and you are adding two complements, it is same as A, so that is not going to affect our equation. Now what are we going to do? We are going to use De Morgan in the inner complement, so it will be then written as B plus A plus B with bar, and then we have to write whole bar. And how are we able to write it? It is because from De Morgan. According to De Morgan, if we are having x dot y whole bar, it will be equal to x bar plus y bar, because we have just broken the inner complement and the upper one is still same. So the same thing has happened over here also. Now let us come to the next term. We will be using the same concept again. The inner bar will be broken and we will be using De Morgan, so it will give us A plus B bar and then whole bar. So this will be my difference equation right now, so I shall note it down. Now we will go to the borrow. Now we know that for half subtractor, borrow will be equal to A bar B. So this A bar B we can also write as A bar into A plus B, because once we multiply A bar into A is 0, so we will get again A bar B. So this can be also written as A bar then A plus B, and we are going to add two complements like this. And now we can again break the inner complement, so it will be again, once we will apply De Morgan, it will be A plus B bar with whole bar. So this gives me the borrow equation. Now we are ready for our logic diagram, because we have received the equation for difference and borrow. Now both equations are ready. Let us make a logic diagram out of it. So we will start with A plus B whole bar. So for that we need a NOR gate. So these are NOR gate with two inputs as A and B. So this output is A plus B with whole bar. So we can see in term 1, let us call the second one as term 2. So in both term 1 and term 2, we are having A plus B whole bar, then B plus A plus B whole bar. It means we can use this output, and this output can be given as input to further two NOR gates like this. Now one of the inputs is A plus B whole bar, which is already given. Now the next input is, we can give here A. In one of them we will give A, in the other one we will give B. So the term we are getting here is what? It is A plus B bar with whole bar. Similarly, the term we are getting at third gate will be B plus A plus B bar with whole bar. Now just look at the difference equation. What is available in between is the plus sign, right? So what are we going to do? We are going to just add it in the form of OR gate. But the point is, the OR gate also needs to be implemented with the concept of NOR gates only. So we will be using one NOR gate over here. So this NOR gate will be then given to one of the gates, which will be again NOR, but that will function as a NOT gate. So what will happen with this is we will be able to convert the negative logic into a positive logic with gate number 5. Let this be gate number 1, 2, 3, 4 and 5. Now what we did here, let us suppose this term is x and let us suppose the next term is equal to y. So what we got here is x plus y with whole bar, right? So what is the output after gate number 5? It is x plus y bar and one more bar, because this next bar is coming because of the NOT gate. So that is nothing but it is equal to x plus y. So that is what we require. We wanted, because we said this term is equal to x, this term is equal to y, and we just needed x plus y. So that is what we have done after gate number 5. So we can safely say then this output that we are getting after gate 5 is nothing but the difference. And what about the borrow? If you will see the term 2, this term 2 which we called as y is nothing but the borrow also. So where are we having this term available? It is at gate number 2 already available. So we can simply say that this is nothing but the borrow also. So again you will realize that we have used just 5 NOR gates. So minimum number of NOR gates required to implement half subtractor will be again equal to 5. So that's it for today's video. In our next video we shall talk about implementation of full subtractors using NAND and NOR gate. Till then, God bless you all and have a nice day.